Hello, it's great to see you again. Before we begin, the knowledge in this video will permanently change your worldview. Over the next 50 minutes, we will together explore every framework of reality from the microscopic world, where the quanta of size are defined. The smallest limit at which magnification becomes impossible up to the largest framework of the macroscopic world, where distance becomes so fantastical that even the speed of light must surrender. And by the time this video ends, you'll have hours to ponder the true place of your music in the universe. Welcome to the smallest to the largest exploration of every dimension of the real world. Chapter 1. A familiar world. Humans, scientifically known as Homo sapiens, are intelligent beings that dominate planet Earth. Once ignorant and self-centered, 21st century humanity has gained a deeper understanding of itself and the vast universe around it. Corpse flowers are a unique genus of parasitic plants. They attract flies for pollination with their enormous flowers, which can be up to 1 meter wide and weigh up to 10 kilograms. It smells like rotten meat. Sorry, everyone, you're all eating now. The dodo is an extinct relative of the pigeon endemic to the Indian Ocean island of Mauritius. They have large bodies, curved beaks, strong legs, and bluish-gray plumage. Unfortunately, their wings were too small for flight, and they were almost defenseless, so humans drove them to extinction. Elephants are the world's largest land mammals, distinguished by their long trunks, large ears, and tusks. There are 3 living species of elephants, the largest of which is the African bush elephant, often used as a unit of measurement for easier visualization. Adult African bush elephants are over 3 meters tall and weigh between 5 and 7 tons, while the largest individuals can reach 4 meters in height and weigh over 10 tons. The T-Rex, or Tyrannosaurus rex, is a genus of giant carnivorous dinosaurs that lived during the late Cretaceous period and is renowned as one of the most apex and fearsome predators to ever exist. The T-Rex had a massive body that could exceed 13 meters in length, up to 4 meters in height, and weigh nearly 9 tons, with a large head, sharp teeth, and 2 strong hind legs while its 2 front legs were small. Their fossils have been found primarily in North America. Blue whales are the largest animals that have ever existed on Earth. When fully grown, they can reach lengths of up to 30 meters and weigh 200 tons. Their tongues weigh as much as 2 cars, and their mouths can hold about 90 cubic meters of water, enough for a family to use for half a year. And their cavernous openings are as big as a plate, large enough for a baby to easily pass through. The Statue of Liberty on Liberty Island, New York, was a gift from the people of France to the United States in 1886. The 46-meter tall statue, placed on a 47-meter pedestal, was forged from thin sheets of copper over a steel frame. The statue was originally a glossy reddish-brown color, but it gradually turned green due to oxidation. The Giza Pyramid Complex in Egypt is home to the Great Pyramid of Giza, the Pyramid of Khafre, and the Pyramid of Menk, along with related pyramid complexes and the Colossal Sphinx, built by the ancient Egyptians 4,600 years ago. The most prominent and massive structure in the complex is the Great Pyramid of Giza, with an original height of 146 meters, making it the tallest man-made structure in the world for nearly 4 centuries. Burj Khalifa is a super-tall skyscraper in Dubai with a height of 828 meters. It has held the title of the world's tallest building since 2009. After surpassing Taipei 101 at 5:08 m, 10 kilometers is the distance where you'll start needing more advanced modes of transportation like cruise ships for a comfortable journey. Within this size range, we have Mount Everest, which is 8,848.86 meters high. This is the highest mountain on Earth above sea level, located in the Himalayas on the border between Nepal and China. If the Mariana Trench were drained and the excavated material pulled ashore, it would be even more majestic than Everest. 10 kilometers is also a size that approaches astronomical scale. We have some well-known celestial bodies within this scope, such as the 2 Mars satellites Deimos and Phobos, or the High Comet. Marathon runners can be proud because their 42 kilometers race looks much more impressive than those celestial objects. Sanan is the size of city. They're the second densest objects in the universe, after black holes. A young star contains about 1.4 solar masses in a diameter of just 20 kilometers. A single teaspoon of matter extracted from behind neutrons, if brought back to Earth, would weigh more than the entire mass of Mount Everest. The dark cluster next to the star Neutron is NX, a natural satellite of Pluto. 1,000 kilometers is an enormous distance, requiring a car, train, or even an airplane. Opening the base for the 1,000-mile club is Ceres, a dwarf planet with a rocky core and icy crust first discovered in 1801. Ceres, musically, is roughly the size of Italy, the U.S. state of Texas, and California. However, it is still smaller than the largest living structure on Earth, the Rano Great Barrier Reef, which stretches 300 kilometers off the coast of Queensland, Australia, and is visible from space. Of course, because it's on par with Pluto, 3,000 kilometers is the range at which you'll find the most important satellites in the solar system. We have Jupiter's moon Europa, 3,100 kilometers wide, Earth's moon, 3,500 kilometers wide, Io, 3,600 kilometers wide, Callisto, 4,800 kilometers wide, and Ganymede, 5,300 kilometers wide, all of Jupiter's moons. In terms of size alone, some of the Galilean moons have actually reached planetary status. Callisto is roughly the same size as glass, while Ganymede is even slightly larger. That's all for fun. But Dad said, this is just a satellite. You're not a very good satellite if you want to have all the planets. Chapter 2. Planets and Stars. Earth at 742 kilometers, is the largest rocky planet in the solar system. Our planet is also the only place in the entire universe where life has ever been discovered. As of now, this is also the size range you'll find after white fur. Most of the stars in our galaxy, including the Sun, will eventually end their life cycle as white vaginas. An amount of matter roughly equivalent to the Sun would be compressed into a volume roughly the size of the Earth, making a teaspoonful of this material weigh approximately 5.5 tons on Earth. Jupiter is the largest planet in the solar system with a diameter of approximately 143,000 kilometers. It's called a failed star. Although it has the composition of a star, it lacks the enormous mass needed to trigger a fusion reaction and produce light. Many scientists believe that for billions of years, Jupiter has protected Earth by deflecting or capturing numerous asteroids and comets with its tremendous gravitational pull, prevent them from colliding with our planet. In other words, without Jupiter, humans would most likely have had no chance to evolve. Add another 0, and we reach the scale of the following ones. The Sun has a diameter of approximately 1.4 million kilometers, more than 100 times the size of the Earth. It is a giant yellow dwarf star that is 6 billion years old. A nuclear reactor at the center of the solar system is hot enough to vaporize diamond. It's so large that it could contain 1.3 million Earths inside, and its light takes 8 minutes to reach us. The Sun was so large it was hard to imagine. However, in the world of stars, the Sun is just an ordinary star. Our neighboring star, Alpha Centauri A, has a diameter of 1.7 million kilometers. Sirius A, or Tianling, the brightest star in the night sky, spans an area of 2.4 million kilometers. The giant star Octer, the third brightest single star in the night sky, has a diameter of 35 million kilometers, 25 times the size of the Sun. Polaris, the famous star known for being less than 1 degree from the North Pole, which helped sailors determine the cardinal directions in the pre-GPS era, had a diameter of up to 64 million kilometers. Both Octer and Polaris are giant stars. Giant star. These are giant stars that swell up in size towards the end of their lives. As a star's fuel-depleted core shrinks, it heats up and triggers fusion in a surrounding hydrogen shell. The energy from nuclear fusion causes the outermost layers of the star to expand, cool, and turn reddish, orange, or yellow. The giant version can be tens to hundreds of times larger than the normal size of a star. In about 5 billion years, the Sun will become a red giant, with a diameter of 140 to 280 million kilometers, which is 100 to 200 times its current diameter, large enough to swallow Earth and even Mars. By the end of 2025, the largest star ever confirmed, Stephenson 2018, will have a diameter 2,150 times that of the Sun, approximately 3 billion kilometers, to save you the trouble of using a calculator. It belongs to the red super-giant class of supergiant stars, and even exceeds the theoretical limits that scientists believe this type of star could exist. If Stephenson 2018 were to replace the Sun, all planets except Uranus and Neptune would be swallowed up. The K-ring is a giant, pancake-shaped ring, approximately 15 billion kilometers in diameter, located at the edge of the solar system beyond Neptune. It comprises billions of icy, celestial bodies, and is the origin of most of the ever-observed comets. By the end of 2025, NASA's V1 spacecraft will be the farthest man-made object, located approximately 25.4 billion kilometers from Earth, and it will take about 23.5 hours for radio signals from the spacecraft to reach us. V1 is expected to surpass the milestone of 1 light day travel, equivalent to approximately 26 billion kilometers, by the end of 2026. From this scale onwards, all familiar comparisons begin to crumble. 1 trillion kilometers takes us into the world of nebulae. Stingray Nebula is the youngest known planetary nebula. Inside this gas-shattering dust cloud, there's a stingray-shaped structure 1.5 trillion kilometers wide, equivalent to 0. 16 times the size of a light bulb. A dying star releases gas outwards, forming glowing outer layers. This is the final stage in the life cycle of low to medium mass stars like the Sun. The Ant Nebula is a large and complex planetary nebula. Streams of gas and dust erupting from the dying star resemble the Sun, creating an ant-like shape when observed from Earth. With a maximum length of nearly 20 trillion kilometers, approximately 2.2 light years. The drawing, one probe would need approximately 37,000 years to travel along this cosmic ant-like trajectory. While planetary nebulae are associated with the death of sun-like stars, stellar nebulae are like nurseries for the future. The luminous columns of the piers of creation are one of the most beautiful images ever taken by Hubble, music, and also one of the most famous astronomical objects. Inside these colossal giants, each about 4 light years tall, gas and cosmic dust are compressed by gravity, forming dense, hot stellar cores. Meanwhile, outside, ultraviolet light and intense stellar winds from newly formed stars sculpt the clouds into iconic shapes. Like the trunk of an elephant, the column of light is just a small part of a much larger structure, the Great Altar Nebula, or M16. M16 is a massive stellar nursery spanning approximately 75 light years, containing thousands of bright and energetic young stars. The Spiderweb Nebula is the largest known nebula, spanning approximately 1,000 light years. This nebula is located within the Large Mall Cloud, a dwarf galaxy orbiting the Milky Way that is about 1/3 the size and 1/3 the mass of the Milky Way. Chapter 3, the galaxy. At a distance of 100,000 light years, we have the Milky Way, the home galaxy of our solar system, and approximately 100 to 400 billion other stars. Galaxies are enormous systems of millions, billions of stars and stellar remnants, gas, cosmic dust, and dark matter bound together by gravitational force. Does light take about 100,000 years to travel across and dissipate? As for one, it would take 1 billion million years to do the first thing. In other words, humanity will never leave its home galaxy. And from this point on, the concept of distance becomes meaningless to humans. The largest known galaxy is IC 101, a supergiant galaxy 5 times wider, and 1,000 times more densely populated than the Milky Way. This enormous size and population are the result of the cannibalism of smaller galaxies over billions of years. 2.5 million light-years is the distance between the Milky Way and the proto-female galaxy, Andromeda. The local group is a cluster of galaxies with a diameter of about 10 million light-years, comprising over 50 galaxies, divided into 2 distinct factions. One faction is led by the Milky Way, the other by the female rulers of the world. Thus, we see that factionalism has been elevated to a cosmic scale. According to cosmic planning, with a vision spanning tens of billions of years, all galaxies belonging to the local group will eventually merge to form a single galaxy with the Milky Way and Andromeda as its core. Located approximately 54 million light-years from our local galaxy cluster is the Virgo cluster. This is a massive galaxy cluster with a diameter of approximately 15 million light-years, containing about 2,000 galaxies, forming the core of the even larger VGO supercluster. Imagine it like this. The local group is a small neighborhood. The VGO cluster is the center of a large city, while the VGO supercluster is an entire vast metropolitan area encompassing 2 female superclusters, approximately 110 million nanometers of light wide, containing about 100 galaxy clusters and over 47,000 galaxies. It is noteworthy that despite the seemingly boundless size of the VG supercluster, this is just one of about 10 million superclusters of music that exist throughout the observable universe. And you might wonder if there's any structure more magnificent than that. Chapter 4. The structure of the universe. Galaxy Philemon filaments are massive, filamentous structures that typically span hundreds of millions of light-years and consist of walls made up of superclusters of galaxies. Galactic fibers connect clusters and superclusters, weaving together the enormous, colossal structure known as the cosmic web, and shaping the overall structure of the observable universe. The Ariannus supervoid is a massive void in the structure of the universe, with massive here being approximately 1 billion light-years wide. The universe is neither literally riddled with holes nor completely empty. The Ariannus supervoid is a region containing significantly less matter, about 30% less than the universe average. In contrast to the Ariannus supercluster, we have the Pisidius supercluster. Within a radius of approximately 1 billion light-years, numerous clusters, superclusters, and galactic filaments coexist and are loosely interconnected within a cosmic web, forming one of the largest known structures in the observable universe. By this point, the numbers have become so ridiculously large and meaningless that they are beyond the comprehension of the biological neons in your or my head. But the universe exists regardless of whether you understand it or not. The Great Wall of Growth, in quotation marks. Hercules Coronalis is a hypothetical filamentous galactic structure that, if confirmed, would become the largest structure ever discovered in the universe, spanning 10 billion light-years, approximately 10% the size of the observable universe. Imagine the universe as a sponge, where the dense areas are where there are many galaxies and the hollow areas are where there are few galaxies. The Hercules Corona Borealis wall is a giant prize in that sponge. And at this point, even the light began to give up. Chapter 5. Limits of observation and communication. The observable universe is a sphere with a diameter of approximately 93 billion light-years, much larger than the universe's age of 13.8 billion light-years due to the expansion of space over the course of light's journey. Light from anything outside this boundary will not have enough time to reach us, and therefore will not be observable. But not being able to see doesn't mean it doesn't exist. According to the theory of the expanding universe, the current size of the entire universe, including everything outside the observable universe, could reach at least 1.5*10 to the power of 34, which is 15 quadrillion light-years, at least 300,000 quadrillion times the size of the observable universe. In other words, we have only seen a very, very small part of a very, very small part of the entire universe. And although there is no evidence, many scientists believe that our universe is just one of an infinite number of parallel cosmic bubbles, floating in metaphysical dimensions, where each universe is fine-tuned to develop. Music evolves and operates according to its own unique physical rules. Chapter 1. The world can see objects at a scale that fits comfortably in the human hand. The standard basketball used in the American Professional Basketball League, NBA, has a diameter of 24 centimeters. Basketball was invented in 1891. The game originally had very simple rules. Players are not allowed to dribble the ball and must throw it into a wooden basket filled with peaches. To eliminate the task of picking up the ball after each score, the bottom of the basket was cut off and gradually replaced with a metal frame and net. Basketball has been an Olympic sport since 1936. Measurement is one of the oldest tools, evolving from primitive measurements using body parts such as footsteps, feet, arm spans, and hands to increasingly precise instruments. The oldest known measuring instrument is a copper alloy rod from the Sumer, music civilization, dating back to approximately 2650 BC. Typical earthworms are typically between 10 and 20 centimeters long. However, their giant earthworm relatives can grow to nearly 3 meters in size with over 500 segments. Hummingbirds are the smallest living relatives of dinosaurs. Of the approximately 375 species of hummingbirds, the Cuban bee hummingbird is the smallest, typically less than 6 centimeters long and weighing less than 2 g, about 5 centimeters of gold for those with oily skin to easily visualize. Shut your mouth. Hummingbirds can flap their wings, or more precisely, rotate them in a figure-8 pattern up to 99 times per second. Their heart rate can exceed 1,000 beats per minute. Their metabolic rate is 77 times faster than humans. Music. They would starve to death if they didn't eat for just a few hours. The Etruscan shrew is the lightest animal in the world that you can find with breasts. Excluding the tail, an adult is only about 4 centimeters long and weighs approximately 1.8 g. They are also the warm-blooded animals with the fastest and most furious heart rate in the universe, reaching a maximum of over 1,500 beats per minute. On average, a chicken egg is about 6.2 centimeters long. Despite being inexpensive, eggs are superfood packed with high-quality protein, healthy fats, and essential vitamins and minerals that benefit almost everyone. In 2025, the world consumed approximately 99 million tons of poultry eggs of all kinds, equivalent to nearly 2 trillion eggs when converted to chicken eggs. On average, each person ate about 240 eggs last year. Because the wave is an electromagnetic wave with a wavelength between infrared and radio waves, ranging from 1 millimeter to 1 m. The wavelength of an electromagnetic wave is the distance between 2 consecutive identical points on the wave. For example, a line from one peak to another, or from one bottom to another, represents a complete cycle. Wavelength is calculated by dividing the speed of light by the frequency of the wave. The microwave oven uses a microwave frequency of 2.45 gigahertz, corresponding to a wavelength of 12 centimeter. This frequency range is effective in stimulating the water molecules to vibrate, thus heating the food from the inside. Theorita magnifica is the world's largest bacterium, so large that it can be seen with the naked eye. If you're curious, you can fly to the Little Antilles archipelago in the Caribbean and turn over the decaying red aquatic leaves in the flooded swamps there to see firsthand the fleshy, bone-like bacteria no bones. They're just 1 to 2 centimeters long. Our village's rice grains, imbued with the alluvial soil of the Kinthe River, are on average about 6 millimeters long, slightly smaller than that of the ants. Although ants can absolutely reach a size of centimeters, such as the Amazonian giant ant, which is up to 4 centimeters long. However, most ants are only a few millimeters long. Here's a riddle. If all the ants on Earth weighed together, which would weigh more, the total amount of rice produced globally in 2025? The correct answer is rice. In 2025, the world will produce approximately 540 million tons of rice. Meanwhile, according to a scientific paper, the number of ants on the planet is around 10 quadrillion, with a total biomass of 12 million tons of dry carbon. From this point on, things become difficult to see with the naked eye, and you'll need a magnifying glass to continue your journey. Chapter 2. The microscopic world sand grains are typically about 0.5 millimeters in size. You need very sharp eyesight to see a single grain of sand. If we assume the average size of each grain of sand and calculate how many grains are in a teaspoon, then multiply that by all the beaches and deserts in the world, the Earth has approximately 2 trillion grains of sand. Meanwhile, the number of stars in the observable universe is estimated to be around 50 trillion, 25 times the number of grains of sand. Dust mites are tiny creatures, about 0.1 to 0.5 millimeters in size, found in almost every household. They hide in fabrics, curtains, even stuffed toys, feeding on dead skin cells from me and you. It can cause itching, allergies, and asthma. Amoebas, or amoeba, are single-celled organisms that live abundantly in stagnant ponds and lakes. They have the ability to constantly change shape by extending and shortening their prosthetic legs, which they use for locomotion and catching prey. Amoeba's dust particles are usually very small, only about 0.2 to 0.3 millimeters in diameter. Exceptionally, there are giant amoeba species that can grow up to a handspan long. A pixel on a liquid crystal display screen ranges in size from 0.12 to 0.3 millimeters, about the thickness of a sheet of paper. LCD screens are flat panel display technologies that use a backlight to project light through a layer of liquid crystals. Each liquid crystal pixel consists of 3 subpixels corresponding to the 3 colors red, green, and blue. When voltage is applied to a pixel, the brightness of each individual pixel changes, thereby mixing together millions of different colors. A 1080p LCD screen has over 2 million pixels. The human egg is one of the largest cells in the body, typically measuring around 100 to 120 microns in diameter, roughly the thickness of a human hair. Sperm cells, on the other hand, are the smallest cells. Although the overall length is up to 50 micrometers, the tip containing all the data for sculpting the baby is only about 4 to 5 micrometers long. The remaining 90% of its length is its tail. An egg cell is 10 million times larger than a sperm cell in volume. At this point, even a magnifying glass would be no match for it. Our next companions will be optical microscopes, using light and a series of lenses to magnify the size of objects. Human skin cells have an average diameter of about 30 microns, too small to be seen with the naked eye. The skin is the largest organ covering the entire body and contributes up to 16% of its mass. Every minute, approximately 40,000 old cells die and slough off the body, creating about 4 pounds of dead cells each year, contributing significantly to the amount of dust in your home. 10 microns is the size scale of a white blood cell. They are the body's suicide warriors, fighting against infections, diseases, invaders, and helping to build immunity. Slightly smaller than white blood cells are chloroplasts, the energy factories of plant cells, where photosynthesis takes place, converting sunlight into chemical energy for the plant while releasing oxygen. Red blood cells and their nuclei are about the same size as chloroplasts. Red blood cells are the most abundant cells in the human body. My body and yours contain approximately 37.2 trillion cells, of which about 20 to 30 trillion are Hong Kong cells. The nucleus of a eukaryotic cell contains the cell's moving material and is the control center that regulates the cell's growth, metabolism, and reproduction. The X chromosome is one of the 2 sex chromosomes in humans, alongside the Y chromosome. Females typically have 2 X chromosomes, while males have 1 X and 1 Y. The X chromosome is approximately 4 micrometers long and carries over 1,000 genes. Y is significantly smaller, only about 1.5 micrometers. 97% of the original genetic code of the Y chromosome has disappeared after millions of years of evolution. Megavirus Horic is the largest virus ever known. At approximately 3.9 microns in diameter, they are 40 times larger than the average virus, even larger than many bacteria. Now we are entering the world of nanotechnology. Chapter 3. The Nano World. Before we get to objects on the nanometer scale, make sure you know just how small a nanometer is. On a measuring tape, you can see tiny lines marking millimeters. You'll have to squint a bit. For every 1 millimeter, divide it into 1,000 equal parts. That's 1,000 microns. Then, divide 1 micron into 1,000 equal parts. So you now have 1,000 nam. Red light, with a wavelength of approximately 750 nanometers, is the first spectrum of the rainbow, and also the longest wavelength of light visible to the human eye. The red light stimulates the appetite to eat. That's why red is so common in the logos of food companies. Conversely, violet light at 400 nanometers is the final band of light in the rainbow, and also the shortest wavelength visible to the human eye. In the past, the color purple was extremely rare and expensive to produce, often associated with royalty, wealth, and power. Today, the color purple is also associated with the LGBTQ+ community. Bacteriophage 200 nan is a group of viruses that infect and devour their prey from the inside out. Bacteriophages are precisely the things that reach the limits of optical microscopy. When light passes through a narrow slit created by two tiny objects located extremely close together, it is bent due to diffraction. When light passes through a lens, it no longer converges perfectly, but creates a patch of light that blurs details smaller than about half the wavelength of the light. Apparent light has wavelengths ranging from 400 to 700 nanometers, corresponding to a minimum resolution of 200 nanometers. To continue our journey, let us quickly head to SPE to order an electron microscope. Electron microscopes operate by using a beam of electrons instead of light. Utilizing shorter wavelengths allows for significantly better resolution compared to optical microscopes. The size of a virus is approximately 100 nanometers. HIV falls within this range. Ultraviolet light, with a wavelength of approximately 60 nanometers, is 1.5 times stronger than the hepatitis B virus and 3.5 times stronger than PCV, one of the simplest and smallest viruses ever known. PCV causes respiratory illness. They only need 2 proteins to multiply. To give you an idea, SARS-CoV-2, the virus that causes COVID-19, has 29 proteins. DNA is very interesting. It has a width of 2 to 5 nanometers, but a length of over 2 billion nanometers, or more than 2 meters if fully straightened. Human DNA, packed into 46 primary chromosomes, is the complete blueprint for life and traits ranging from my color, height, blood type, to susceptibility to disease and lifespan. 5 nanometers is also the size of modern transistors. Transistors are tiny electronic devices. Its on and off states generate the binary code that underpins digital computing. A modern chip today contains tens or even hundreds of billions of transistors. The 1-2 nanometer alpha helix is a crucial secondary structure of proteins that allows them to fold into specific 3D shapes that determine their function. Carbon nanotubes are the most durable material known. It possesses tensile strength approximately 100 times greater than steel. A single-walled carbon nanotube is essentially a sheet of graphite 1 atom thick rolled into a tube with a diameter of approximately 1 nanometer. And from here, we enter the quantum realm, where all descriptions of size and even the classical laws of physics begin to fade away. Chapter 4. The Quantum Domain. A quantum is the minimum quantity of any physical entity. Simply put, quantum particles are the smallest components of the natural world. The single-line element has a diameter of approximately 800 picoms. Plants produce simple sugars through photosynthesis before linking them into more complex molecules called carbohydrates. Humans eat plants and break down carbohydrates into simple sugars to produce energy. The X-rays that pass through your body each time you take an X-ray have a wavelength of approximately 500 picocoulomb. X-rays easily penetrate air and soft tissues such as skin, muscle, and fat, but are absorbed by denser bone tissue, resulting in a white appearance on the film. 500 Potters is also the size of one of the largest known atoms. Cesium is a soft, yellowish silver metal that melts in the palm of your hand. The large size of cesium is due to its many electron shells, which cause the outermost electrons to be very far from the nucleus. Even as a single atom, cesium is larger than a water molecule composed of 2 hydrogen atoms and 1 oxygen atom. A carbon atom has a diameter of approximately 160 picometers. All life forms on Earth are carbon-based life forms. Because the essential building blocks of all living organisms, from proteins and DNA to lipids and carbohydrates, all have a skeleton made of carbon atoms. Carbon can form 4 strong bonds simultaneously, allowing it to bond with many other elements, as well as with itself, to create diverse and complex biological macromolecules essential for life. Hero, with a diameter of 110 picophora, is the simplest and most abundant element in the universe. Essentially, it consists of a positively charged proton attracting a negatively charged electron. According to estimates, the observable universe contains approximately 10 to the power of 80, which is 1 followed by 80 atomic zeros. 90% of it is hydrogen. Helium 25 picometers is the smallest atom in the periodic table, smaller than even a heteroatom, because its 2 protons create a stronger attraction between its 2 electrons, pulling them closer to the nucleus. Even an electron microscope will be no match for this. The scale of objects exists only in equations. The current limitations of electron microscopes are limited to a scale of approximately 50 picometers. At the picomet scale, corresponding to 1/1000 billionth of a meter, the electron beam no longer focuses precisely after passing through the electron lens. This is called optical aberration, which causes the image to appear blurry. Furthermore, atoms are never at rest, but are always undergoing thermal oscillations and possess a quantum uncertainty, so their positions in space are already opened by several tens of picobets. Furthermore, unlike light, electrons are charged and interact very strongly with matter, causing multiple scatterings and resulting in spatial information loss over extremely short distances. Although invisible, the size of a helium atom can be calculated theoretically or measured indirectly. The gamma rays that transformed Dr. Banner into the green giant had a wavelength of approximately 10 pico. That means gamma photons oscillate up to 30 quadrillion times per second. Oh, and it's not actually blue like you see in a movie. A uranium nucleus with a diameter of 12 is the largest naturally occurring nucleus, containing 92 photons and approximately 140 neutrons. The decay of uranium-238 isotope, containing 146 neutrons, is crucial evidence suggesting that the Earth is approximately 4.54 billion years old. Atomic nuclei and protons are too small to be seen or measured directly. Instead, they would fire beams of electrons at them, analyze the electrons that are deflected after the interaction, and from that deduce the charge distribution, as well as the size of these particles. This is known as high-energy electron scattering and is one of the methods used to determine the size of ultrafine particles. Unlike nuclei, modern physics considers electrons to be point particles, meaning that their finite size, shape, or internal structure has not yet been observed. This description doesn't assert that the electron is actually structureless or zero in size, but rather reflects the limitations of modern scientific understanding. However, by making the rest energy of the electron equal to the potential energy of a charged sphere, one can deduce that the classical electron radius falls around 2.82 m. In 1940, physicist John Ward proposed that all electrons in the universe are the same single electron moving back and forth in time. This is known as the one-electron cosmology. Protons and neutrons are essential components of the atomic nucleus. They are hundreds of thousands of times smaller than the atom itself and measure about 1 to 2 centimeters. The weak nuclear force has an extremely short range of about 1/4,000,000th of a meter, thousands of times smaller than the diameter of a proton. The weak nuclear force is one of the 4 fundamental forces of the universe, alongside the electromagnetic force, the strong nuclear force, and gravity. It allows the beta decay process to occur, transforming one element into another, and also acts as the initiator for fusion reactions within subsequent stars. Two are the fundamental particles that make up protons and neutrons, the building blocks of the atomic nucleus and most of the visible matter in the universe. Like electrons, particles are also considered point particles. So far, science has only been able to determine their upper limits. That is to say, if there is a size, the quale must be smaller than the threshold that current experiments have been able to solve. Somewhere on the atomic scale, millions of times smaller than a proton. Quack is like ice cream because it has 6 flavors that are captivating, with unique peaks and valleys. In that, the up and down musical, quacking is the most common way to combine to form protons and neutrons. Heavier, more cumulonimbus cables only appear in particle accelerators or space shuttles. Experiments have shown that neutrinos behave like point particles down to the Zometer scale of about 1/1,000,000th of a quadrillionth of a meter. Every second, hundreds of trillions of neutrinos from the sun pass through your body, most of which don't interact, earning them the nickname ghost particles. Neutrinos interact primarily through the weak nuclear force, but this weak force has an extremely short range of action. They also interact with gravity, but they are incredibly small and almost massless. In theory, a neutrino could travel for billions or tens of billions of years without interacting with any matter. Chapter 5. Planck length. The Planck length is the theoretical minimum distance in space. It is where classical concepts of distance and geometry collapse, where all measurements lose their meaning. There is absolutely no concise way to grasp Planck length other than through dry numbers. The length of a Planck is 10 to the power of minus 35 m, which is trillions of times smaller than the atomic nucleus. Don't misunderstand, long things aren't necessarily the smallest size in nature. It's more accurately described as the limitations of current physics applications. To illustrate, if you apply the energy required to measure a distance smaller than the planned length to a distance smaller than the planned length, the energy density becomes high enough to create an energy blast hole that collapses the area being measured. At Planck scale, there is no bubbling time. Quantum bubbles, also known as space-time bubbles, are a theoretical concept first proposed by physicist John Weir. In 1955, it was like a sea of bubbles constantly forming and bursting on the smallest scale of the universe. Einstein's theory of general relativity describes gravity as a manifestation of a curved and smooth spacetime. Conversely, the uncertainty principle of quantum mechanics states that at the microscopic scale, energy is not stationary, but is always in flux. Virtual pairs of particles and antiparticles are constantly being created and then disappearing in very short periods of time. When applying the uncertainty principle of quantum mechanics to the copac of spacetime, energy fluctuations cause spacetime to become rough, bumpy, and frothy. This is quantum foam. In string theory, fundamental particles are replaced by thin 1D threads approximately the length of a Planck. Each unique vibration pattern of the string corresponds to a type of fundamental particle, such as an electron, proton, or other particle. Imagine them as the strings of a musical instrument, producing many notes to create the symphony of the physical world. Loop quantum gravity theory, however, goes in the opposite direction. Instead of quantizing the particle, it quantizes spacetime itself. In the spacetime Planck, the spacetime is no longer a smooth, continuous loop, but is composed of small, discrete loops, much like how an LCD screen is made up of pixels. Thus, we have just explored together the most extreme scales of size that reach the breaking point of physics and theory. The Planck length may be the smallest resolution of the universe, but it's also possible that even deeper layers of reality lie beneath it. These are wires, loops, structures that we don't yet have a language to name. Humans seem to be trapped in a very strange place. We are too small to reach the vastest edge of the universe and seem too large to penetrate the quantum realm and see into the very essence of existence. Music, but it is precisely in this hesitant position of music that people have questioned, measured, and imagined music, gradually uncovering secrets far greater than they themselves knew. And if you feel enlightened after watching this video, please hit the like button so I know. To follow the most captivating and twisted cosmic content, remember to subscribe to the channel and ring the bell. And now, goodbye and see you again.